So for this problem, we have when 63.1 grams of hydrochloric acid, so hydrochloric acid, reacts with 17.2 grams of oxygen gas. Oxygen's a diatom. No, this is gas. This is aqueous. 49.3 grams of chlorine gas is captured. So I'm going to highlight this guy. If it's captured, that's the same as saying obtained. So that's going to be for percent yield. Okay. What is the theoretical yield of the chlorine, the percent yield, the excess reactant, limiting reactant, and the amount of excess left over? All right, so let's take a look at our reaction here. We look like a single displacement, an anionic one. So I'm going to get H2O and chlorine, which I know chlorine gas to be a diatom. Reason for that, I noticed that I've got my hydrogen, I've got chlorine. This guy is an anion because he's a nonmetal, and oxygen is an anion, so it's going to be an anionic single displacement, and that's how the hydrogen hooked up with the oxygen to get water, and the chlorine's by himself. Okay, so now we balance it. I'm going to put a 2 here. That gets me 2 hydrogens, 2 chlorines. I had 2 oxygen, so actually we're going to have to change that and make this be a 4 and make that be a 2. So let's just check really quickly here. We've got 4 hydrogen, 4 hydrogen, 4 Cl, 4 Cl, 2 oxygen, 2 oxygen. We're balanced. Okay, so now to start our stoich. We've got 63.1 grams of the HCl, and we are going to run that over to our chlorine. So grams of HCl comes down to moles of HCl. Moles of HCl comes down, and we are going to go moles of chlorine. Mole of chlorine is going to go to gram of chlorine. So this is our first stoich. We've got 1, and our mass is 36.5. I get that from the hydrogen being 1 on the periodic table and chlorine being 35.5. Mole to mole, I have 4 moles of HCl and 2 moles of chlorine gas. Last one, 1 mole of chlorine gas. Chlorine is 35.5, but there's 2 of them, so 71 is going to be right there. To multiply everything on top divided by everybody on the bottom, I'm going to enter it in my calculator as 63.1 times 2 times 71, hit equals, divide, left parenthesis, 36.5 times 4, right parenthesis, and then equals. And I get 61.4 grams of Cl2 is possible from the hydrochloric acid. Okay, now remember, this is not our answer yet. This is just what's kind of possible. So I'm going to put a box around it and say, okay, this is a possibility. So now we're going to go over to our 17.2 grams of oxygen gas. Our second one, we have 17.2 grams of oxygen over 1. Our gram of oxygen goes to moles of oxygen. Our moles of oxygen goes to moles of chlorine. And our moles of chlorine goes to grams of chlorine. So 1 mole is 32 grams. Oxygen is 16 on the periodic table, but there's 2 of them. That's where we get our 32. Now our mole to mole. We only have 1 mole of O2, and we have 2 moles of Cl2. We now have 1 mole is 71 grams, which we did on the last problem. We're going to multiply everybody on top. So in your calculator, you're going to take 17.2 times 2 times 71 equals divided by 32. That gets me 76.3 grams of Cl2 as a possibility. So from this moment right here, we know that our theoretical yield is the 61.4 grams of chlorine. The 76.3 didn't happen. That makes our excess reactant the oxygen. That makes our limiting reactant the hydrochloric. So limiting reactant is the HCl because it produced the smaller amount. The excess reactant is oxygen. Our theoretical yield is 61.4 grams of Cl2. We could go ahead and do percent yield. They're telling us that 49.3 grams of chlorine gas was captured, so obtained in the lab. 61.4 grams is what you theoretically should have been able to get. So we're going to multiply that by 100 once we do our dividing, figure out how much we yielded out of this. So 49.3 divided by 61.4 gets us 80.3%. So our percent yield here is 80.3%. Our last part. We want to know how much excess was actually used and how much is left over then. So we started with 17.2 grams of oxygen, but that didn't happen. Remember, like this was the excess reactant. So we're going to take our 61.4 grams of Cl2, which was our theoretical yield, and remember we're going to flip this and reverse it. So grams of Cl2 goes to moles of Cl2. And then you're going to go moles of Cl2 to moles of our oxygen, which is our excess reactant, and then moles of oxygen to grams of oxygen. And remember, this has all been done for you, so you just flip and reverse it. So 2 and 1 and 71 and 1. So by multiplying our 61.4 times 32, dividing by left parenthesis 71 times 2, right parenthesis equals. I got 13.8. I might check that again just because my calculator went a little wonky. Okay, they gave us 17.2 grams of oxygen. That's what you got in the beginning problem. We used 13.8 grams. Okay, because think about what you just did here. You took the yield, how much the theoretical yield should be, and you striked it back to go, okay, if I know this answer to be true, then how much oxygen did I use? That's where this 13.8 comes from. You now take that 17.2, that was how much they gave you to use, minus your 13.8, and you find that you had 3.4 grams of oxygen left over.